Well, today we're talking about the Pacific Water Shrew, Sorex indiri, which is a native shrew here in the Pacific Northwest. It's critically endangered in British Columbia. It's federally listed as endangered in Canada. In the US, it has no protections. In the environmental field, I'm always putting something in the context of, what financial benefit for humans does this have? What, large-scale ecosystem benefit does it have to some degree? But really what everything comes down to for funding is generally how does it help people? These shrews do help promote the exchange of nutrients from aquatic to terrestrial systems. They're so rare that it's probably not a ton of it, but they do have ecosystem function. And for all we know, they control some macroinvertebrate species that would go totally out of control if they didn't exist. We just don't know. Like, these things evolved to live in ecosystems for a reason. They have intrinsic value, and by our laws, if they have declining populations, which Canada has already said they do, they should be protected. So what we have here is actually not a Pacific Water Shrew because they're so rare, but this is another shrew in the genus Sorex, and so really the only difference visually is going to be that Pacific water shrews are kind of a more gray color. But the main reason why I brought this guy today is to just kind of help people differentiate between shrews and rodents. So as you can see, they don't even have visible ears, and they also have a really long pointy snout, more so than rodents. And they have very, very tiny eyes. They're almost blind. They rely primarily on smell and other senses and not sight. Something that's really cool about Pacific water shrews is that they're able to smell their prey underwater, because almost all of their prey comes from underwater. They eat stuff like caddis and other benthic macroinvertebrates, sometimes crayfish, small fish, stuff like that. And the way they do that is they blow out bubbles that they then suck back in, and they smell. They smell underwater just by blowing bubbles and sucking them back in. And something else that's really interesting about them is one of their common names is the Jesus shrew, because they can walk on water, because they've evolved these pockets of air in their fur that function more or less like a life vest, and they can actually run on the surface of water for several seconds. So if you're on the west coast of North America, from California up to southern British Columbia, and you're seeing small mammals running around on the surface of the water, there's a decent chance that it's some kind of water shrew, and it could be the Pacific water shrew. There's also like the American water shrew that's a little more common, but also not real common itself. So here at Nature's Haven, we're surveying for these things, and we're doing that by using what's called a hair tube. So it's a non-invasive survey technique, which is really easy and cheap to make. It's literally just a short, about 8-inch long PVC pipe that you cut a slit in, and then you affix an adhesive. Even duct tape would work with the sticky side facing down. And then this other duct tape is here to just hold that adhesive wafer in place. And the idea is that shrews will pass through the tube, and then as they do so, they'll leave hair on the adhesive that we can then look at under a microscope sometimes, or it also occasionally needs to be sent off to a lab for genetic analysis. You can determine what's been passing through the tube by looking at the hair that's left on the adhesive. So we're going to put a little smoked salmon in it today over in some skunk cabbage. The hair tubes are so good to use for small mammal monitoring, and with shrews in particular, is because before these were developed, people were using pitfall traps that were basically like a coffee can in the ground, that was baited, and they would run along and they'd fall in. But the thing with shrews is that they need to eat every 2 hours or they'll die. So you have to be checking these traps literally like every hour. Otherwise, you're potentially like wiping out a critically endangered species just to try to determine if it's somewhere. So with this, it's a lot more passive. They just leave some hair, and it's a great way to determine presence at a site.